This will be relatively quick. I just want to talk very briefly about the effects of altitude on partial pressure and its consequences in our respiratory system. As I mentioned earlier, the pressure of the gases, the atmospheric pressure changes the farther away you get from the center of the Earth. Due to gravitational pull, the atmosphere is more dense near the Earth, and it's less dense when you get farther away from the center of that Earth. And we can actually see this reflected in atmospheric pressure. And so we're going to take a closer look at the first two columns. And notice at sea level, my 0, we have atmospheric pressure on average of 760. If we increase to about 2,000 feet above sea level, that's going to change to about 707. If we carry that further, and I'm going to actually jump all the way up to 10,000 feet. I grew up in Colorado, so we often would climb these 14-footers. I never climbed Pikes Peak, but I did climb a few of the other ones. And at 14,000 feet, we would be in between this 523 and this 349. Just for reference, because it's really quite cool, there's some values down here. You can see Mount Whitney in California, 14,505, Mount Logan in Canada, 19,524, Mount McKinley in Alaska, and then of course the well-known tallest mountain in the world, Mount Everest, 29,029. Let's take a look at that 30,000. Just for how mind-boggling it is. At 30,000, we're dealing with a whopping 226 millimeters of mercury of atmospheric pressure. Let's look at what that does to oxygen. Atmospheric pressure, partial pressure of oxygen in the at sea level. Okay, is that 160 or that 155? Partial pressure of oxygen as we climb up. Let's go ahead and just look at 10,000 here. 109. Okay, 109. And so remember that in the alveoli itself, it's going to change. So let's go ahead and look at that. In the alveoli at sea level, we're at about 100 millimeters of mercury, going over to this 109, 74 millimeters of mercury. And the ability then to drive oxygen into the bloodstream changes based on these changes in partial pressures. Okay, it's actually quite important and relevant to understand that. In fact, if we look on the very next column, we can actually see how these partial pressures affect how much oxygen is present in the bloodstream. When we have a partial pressure of 105 millimeters of mercury, or about 100 millimeters of mercury, the arterial blood that leaves the lungs, that goes from the lungs back to the heart, has a partial pressure of 100 millimeters of mercury. It's matchy-matchy. They're very, very similar values. And that's because the oxygen actually has time to move until the pressure is at equilibrium or close to equilibrium. Looking down here, we see that that process is less effective because the driving force, as the partial pressure of oxygen drops, the driving force that favors the movement of oxygen into the bloodstream drops too. And you can see that decrease. And that decrease represents the ability of the lungs to supply our body with needed oxygen. Now, there are other physiological consequences, as you learned in the hematology lectures. Our body does compensate over time. It takes a little while. It takes at least 2 weeks before the spleen releases its excess red blood cells into the blood, and the bone marrow releases newly formed red blood cells. It takes at least 2 weeks before you start to notice an increase in hemoglobin content in the blood, and therefore your ability to bind up more oxygen would actually go up. But if you do what I did, I grew up in Colorado, okay, and like I mentioned, if I but now I'm living at sea level. If I suddenly go visit my sister in Colorado and she decides to take me for a drive and we're going to go up the mountains to Leadville, which is actually 9,000 feet, I'm very quickly going to feel like I am out of breath because I don't have those adaptations yet. I haven't produced more hemoglobin yet. And so that results in the shortness of breath, which can lead to altitude sickness. And in the case of Mount Everest, let's look at those values there. It's very, very difficult. In fact, I don't want to say an exact number, maybe 2, 3, a very small percentage of people, small number of people have successfully climbed Mount Everest without oxygen tanks. And the reason for that is that if you look at this, obviously our oxygen levels in our bloodstream are so very low, our tissues are starving for oxygen, and we end up getting some confusion and some serious hypoxia, which refers to low oxygen levels. And so that's kind of interesting and important. And I talked a little longer than I meant to, but kind of fun and interesting how altitude affects partial pressure.